and welcome to another episode of FooBar. In today's video, I want to talk about step functions service integration patterns, as this video is part of a series about step functions in where you can learn all the basics and more advanced concepts about step functions so you can start working with them. In this video, you will learn what are the service integration patterns. There are 3 patterns available, so we will cover them all. So let's get started. Service integration patterns are the different ways that step functions integrate directly using the task state types. I have a whole video on that. You can check it in the description box with the different AWS services and any kind of resource that you're calling. You can call a service from a workflow, and there is 3 types of integration patterns. The first one is that you can call a service from a workflow and let the step functions progress to the next step immediately after it receives the response from the operation that it called. The second way is you can call a service and have step functions to pause the workflow until the job completes. And the third way is that you can call a service using a task token and have step functions pause the workflow until that token is returned. And let's look now what are exactly these 3 different patterns, when to use them, because the last 2 sound similar and you might be wondering why one or the other. So let's go more in detail and check them out. The first service integration pattern I want to cover is the simplest one, the request response one. To implement this pattern, you need to specify a service in the resource string of your task state, and you will only provide that API as we see in the slide. That can be an optimized integration or an AWS SDK integration. And this is the way that we have been invoking the states through the whole series. So that's maybe something you have seen a million times already. When this happens, step functions will call the API and wait for that HTTP response and then progress to the next step. In this diagram, you can see a workflow that we are calling S3, and this is a synchronous request. Basically, when S3 responds with the object, step functions will move to the next state in the workflow. The next step is also a synchronous request and is invoking a Lambda function synchronously. This means that step functions will wait for that Lambda function to complete and get the response from the function into its output. But if in the case that we call this function using the asynchronous API, then what will happen is that step functions will send the request, get the acknowledgement from the function that the function started, and then move on to the next step, as we can see here with Event Bridge. In this case, it's an asynchronous API to put an event into Event Bridge, and this function will just publish the event and then move on because it received the acknowledgement from Event Bridge. The second integration pattern available in step functions allows you to call a long-running API and have a step function pause the workflow until the job completes. This is something very useful. So your state machine can be paused and not costing anything during this time. This pattern is only available in standard state machines, in standard workflows that you can run up to 1 year. And this means that you can have your state machine pause up to that year, so that's great. When working with standard state machines, you only pay for the state transitions, so this is why this managed wait is very handy. The thing with this type of integration pattern that it can only be done in a selected group of services that are called the integrated integration, like batch, ECS, step functions. I will leave you a link in the description box and I will show you some in the next slides. So if you want to get started with it, basically you need to define your state, task state, and in the resource, what you will do is append .sync into the API. And in that way, you will get started. And in here, you can see the state machine that is querying Athena using that integrated integration that has a support with the .sync. So we will see it in the query of the data set. And basically in the side, you can see all the services that have support for this integration pattern, and it's not available for the AWS SDK. So that's important to know. and the link is in the description box, don't forget, of all the different services. So now step functions will do a call to that API to query the dataset with the .sync, and it will call Athena, and the step function will pause until the Athena service completes its API, its request. When Athena completes, then the workflow will start again and will start from the next step. In this case is to get the results. That is a synchronous call, request response, typical. It asks for the results, it gets them in the output. And then finally we call event bridge and we put an event in an asynchronous manner, but again it's using the request response pattern. The last integration pattern available for step functions is called wait for callback. In here you can call a service, and it doesn't matter what kind of service, everything works, and you will call it with a task token that the step function will generate for you, and step functions will pause the workflow until that task token is returned. This pattern is extremely useful because as it allows you to integrate with basically anything, you can connect it to any AWS service, you can connect it to different legacy services, external services, or even manual operations. So if you have seen our samples on Serverless Espresso, that is our kind of coffee ordering shop that we put at events, basically the coffee ordering process is handled with a workflow. And in some point of that workflow, we have manual integration between the user and the ordering process, where the user needs to select what kind of drink they want. They want cappuccino, they want espresso, they want whatever. And basically, this is a manual integration. So we are waiting for the customer to select the drink. And because a step function has so many operations related to error handling and handling of state, we can attach, for example, wait time of 5 minutes. So if the customer doesn't decide its order in 5 minutes, this operation will time out and the workflow will fail. And if the customer picks something like a cappuccino, then an event will be emitted and with the task token start the execution again. Again, this pattern is also available in standard workflows. In here, you can see how we are calling that API. So basically, we call the API as we normally will do, and then we attach at the end .wait for task token, and then basically the task token will be available for you to get it from your context object, and is getting there in the message body that we are passing to the next event. And it's important to save the task token as you will need it later in order to resume the execution. So let's see the example. Here we have a workflow that puts a message into a queue to start some work, maybe talking to some legacy service or something like that. And in the case that this task succeeds, then the workflow completes, everything is good. In the case that the task fails, then a function will be invoked, the error will be handled, and then the workflow will fail. So now we are basically putting a message in a queue with this wait for task token. The task token is generated, is stored somehow, somewhere. Usually Dynamo is a good place to store these things, but you can do whatever you want with it, and it's sent to this receiver service that it can be a Lambda function, a container, legacy service, whatever. We don't care for this particular use case. And then when the task that we want to wait for completes in the receiver of the task token, and then we can use the AWS API, send task success with the task token to continue the execution of the state machine successfully, everything is good. And if there is any problem, we can send the same, a different call, send task failure with the task token to say, okay, the task failed, and it will move to the fail branch. So that was the video for me today. I hope you like it. I hope now you understand a little bit better on how step functions are working. We will look at more details in these patterns in the future episodes. Let me know in the comment box below what particular patterns you have in mind, which ones you would like me to build demos for. Is there something that you are interested in? I'm more than happy to go in depth in some of these examples. And if you are a little bit lost with some of the step function concepts that I presented in this video, I have a full video talking about the different tasks, the workflow types, the state management and things like that, where we go in depth. So I leave it here so you can go and check it out. And if not, go and check the playlist where all the videos are listed for this series. And I see you in another episode of FooBar. Ciao, ciao!